In today's lesson, we will use FlowWorks to model fluid flow through a variety of shapes to study their effects. Let's turn it over to Jesse now as he leads us through this lesson.
Today I will be showing you how to evaluate the aerodynamic qualities of a part in FlowWorks. To do this, I am going to be using a simple hollow cylinder. To use FlowWorks, you need to have a part that has one interior chamber that is completely sealed from the outside. To do that, I'm going to draw a simple cylinder that I will revolve around this line of infinite length. But I will also put another cylinder inside of it. So when I extrude this part, I will have a hollow inside my cylinder. Although length does not matter on this, I shall make my cylinder 5 inches tall on the inside. The walls will be 1/10 of an inch thick, and the radius will be 2.5 inches. This only needs to be big enough to fit your entire part. Now I will be giving the fluid an obstacle to its path. I am doing this inside of my part because it is going to be a round platform with a hole in the middle. You may have to do it later after you are done making your chamber. It can be a little bit difficult to get the parts inside the chamber, but there is usually a way. I'm going to make this 2¼ inches high. So we have 1/2 inch for the fluid to get through from one side to the other. Now I'm going to revolve this around the center line. Now, one of the more important parts of FlowWorks. I'm going to take a cross section of my part so I can see inside of it. You can also apply a clear color to your part if you wish. Now that we have our chamber that we are going to test, I shall start doing FlowWorks. Flow is found over in the Evaluate tab and then Flow Express Analysis Wizard. You click that and it will tell you you have to save your model before. This is because Flow can crash your computer. I'm going to save this as air chamber. Now we can begin flow analysis. The first screen you will see is this screen. This screen is not actually part of doing flow. It just tells you what you need to do it. You need one closed place with a lid on each end. The lid does not have to be a separate part. It can be any surface that is inside the chamber. And of course there's a disclaimer saying don't base your results on this. You want to click the next button. Don't click the check in any part of this process because it will just close it. And you'll have to open it again and it's annoying. This will show you how much fluid you have. As you can see, there's a small gap where we don't have fluid. It is just to check and see if your part is okay. This is where we select air or water. You'll want to select water for this. Air can get really weird really fast. This is where you select the input face, which is going to be this one, and also the amount of fluid coming out of it. I like to use volume, and I like to put in a fairly high flow rate because it gets faster flows. This is where we pick the output face and the pressure it has. Just leave it with the default pressure. Then you solve it. Solving can take a while. Once you have finished solving your part, this window will come up. The default setting is 20 pipes to show how the flow is. With 20 pipes, you can see that the flow will compress into a small area and then shoot out in a tight tube. I like more pipes because it shows more flows. You can also have it display ball streams. These are more useful when you go to animate. If you are using pipes and you hit play, it will draw the pipe from the beginning and you can watch it shoot out. If you are using balls, it will draw a stream and all the particles will be moving at once, so you can compare relative speeds. The inlet or outlet settings, I like to leave it inlet. With outlet, they can be weird. Here's an example of outlet. When I animate that, you can see that all of the streams will curve in from over there and then plunge into the bottom. Should be noted that this face is the outlet and this face is the inlet. This flow is not coming from the inlet at all. The same story is true with the balls. So leave it on inlet. There are times when they yield the same result, but it is not likely.
So here we've modeled up a shape protruding into our cylinder, and we can analyze the flows going around this shape and how they kind of constrict inside the tunnel. Now I'd like to show you something you can do with this. I took this rutan wing and placed it in sort of a wind tunnel. The problem with FlowWorks Express or Flow Express right now is that it only will do internal flows, and so it won't do external flows. And really, to test this airfoil very well, we would need an external flow on it. I put the wing in a little box and started through the wizard, and here's the result. Here's another wing inside a different wind tunnel. This one's a circular wind tunnel and a different wing profile. Another thing you could do is, instead of having your profile go all the way through the tunnel, is to simply put it hanging in space inside the tunnel like this block is. This block gives some interesting effects when we change some of these parameters of our animation. Here's a nice little teardrop shape that should be fairly aerodynamic as compared to that block. Let's change the parameters on this animation and see what happens on the output side. Oh yeah, blue spaghetti. Almost feel like I'm watching Dorothy in Kansas here. Now, you can really start to mess with this thing. Notice that the inlet is on one side of this left-hand disc and the outlet is on the far side of the right-hand disc. So the air flowing through there has to go way around. And if we change the animation to the output side, the outlet, let's see the result. Yeah, this is how we make little blue Tasmanian devils.